agents are the new apps.
So I think we're going to live in a world where there are going to be hundreds of millions of billions of different AI agents, eventually probably more AI agents than there are people in the world.
For the very first time, this is going to be an industry of skills. And you capture that phrase and you call it agents.
Everyone's talking about AI agents right now, but even big companies like Apple and Amazon can't get them to work right. Apple just had to pull back their Apple Intelligence features because it was making up information in the summaries that their AI was providing. Amazon has the same problem putting AI into Alexa because of these made-up answers. And when you look online, you see countless YouTube videos and blog posts where people claim they're building the most amazing AI agents. And everyone has their own approach and tools that they swear by. Now let me be blunt. Creating AI agents that perform reliably is far harder than most people realize. Those impressive tech demos circulating online show carefully controlled scenarios with perfect inputs. They reveal what's theoretically possible, but hide how fragile these systems really are. When faced with diverse users asking unexpected questions, even the most polished demos typically crumble. In this video, I'm going to share practical approaches for building AI systems that actually work when deployed. I won't pretend to have perfect answers, but I'll walk you through the most valuable lessons I've learned while building AI solutions for real clients over the last 2 years. I'll also include insights from companies who are making real progress on these tough AI challenges. And now, if you're new to the channel, my name is Chris. I'm the co-founder of Tech. I hold a bachelor's degree in data science, and my journey with AI started about 2 years ago. For the last 2 years, we've been building custom data and AI solutions for our clients. Next to that, I also advise in a bunch of communities with thousands of AI developers. I make these videos to help you level up and become a better engineer, so perhaps eventually you might want to join us. Alright, so let's first talk about what AI agents actually are, because before we can build them, we first need to be all on the same page about what they are, right? Now, the term AI agent has become incredibly popular, but there's significant confusion about what it actually means. When 10 different developers talk about AI agents, you might hear 10 completely different interpretations. This confusion becomes obvious when examining online resources. Most tutorials labeled "How to build an AI agent" simply describe applications that incorporate an LLM API call somewhere in their execution flow. Now, why has this term become so diluted? It's largely because agent sounds cutting edge and impressive, but behind this terminology confusion lies a legitimate desire. Developers want to create systems that can independently handle complex tasks. At Tech, we prefer to use the more precise terminology of AI systems as a broader category, with AI agents representing a specific, more sophisticated subset of these systems. For clarity, I'll reference a framework developed by Anthropic that captures our thinking on this topic. In their guide on agent development, they establish a crucial distinction. They define workflows as systems that orchestrate LLMs and tools through predefined pathways in code. This encompasses most implementations that we see today. True agents, by contrast, are systems where LLMs autonomously manage their own processes and tool selection, retaining control over how they accomplish objectives. Understanding this distinction isn't just academic. It fundamentally affects your development approach and what technologies you should deploy for different use cases. It's the difference between building a rigid system that works reliably within narrow parameters versus creating something with more flexibility but potentially less predictability. Core concept 1, foundations. Now let's talk about the practical aspects of building effective AI systems. Your first decision as a developer is choosing your technology stack. Those comfortable with coding might use languages like Python, JavaScript, or Rust. If you're less technical, visual platforms like N8N, BotPress, or ManyChat offer easier alternatives. But here's something important. The specific technologies you choose aren't the main factor in success. What matters most are the architectural patterns and design principles you use in your solution. Let me walk you through the fundamental building blocks that form the foundation of any effective AI system. And these concepts apply no matter what tech stack you use. At the core of every AI system is what I call the enhanced language model, starting with a basic LLM and extending its capabilities through 3 critical components. The first is knowledge access. This lets your system pull information from external sources, databases, documents, or APIs, and feed it into the LLM's reasoning process. Most of the time, this uses vector embeddings and semantic search, often called RAG, which stands for Retrieval Augmented Generation. Knowledge access is similar to providing your AI system with a library of information it can look up whenever it needs to check for facts or details. Just like a doctor that might check medical journals, your AI can access specialized information beyond its training data. However, the quality of information retrieved depends heavily on how you organize and search your knowledge base. The second component is function execution. This enables your AI system to perform actions in the real world, whether it's checking the weather, booking appointments, or analyzing data. Instead of just generating text, the system can connect with external services to accomplish specific tasks. The third component is contextual awareness. This refers to the system's ability to understand and remember ongoing conversations. Each interaction builds on the previous ones and helps your AI remember the whole conversation, not just the last thing that you said. When these three components work together effectively, they transform a basic language model into something much more powerful. A system that can access specialized knowledge, perform meaningful actions, and maintain coherent interactions over time. And the result of this is an AI solution that delivers real value rather than just impressive sounding responses. Core concept 2, patterns and approaches. Now that we've understood the basic building blocks, let's look at the different ways that we can structure our AI systems, from simplest to the most complex. The first pattern is what I call single-step processing. This is the most straightforward approach. Your application sends a prompt to an LLM and uses a response directly. While simple, this actually works surprisingly well for clearly defined tasks like text summarization, sentiment analysis, or basic content generation. The key is crafting precise prompts and setting clear expectations. For many business applications, this pattern alone can deliver significant value with minimal complexity. Moving up in complexity, we have the sequential chain pattern. Here, you can break a complex task into a series of smaller steps, with each step handled by a separate LLM call. For example, when creating a blog post, you might first generate an outline, then write each section separately, and finally create a conclusion. This approach gives you more control and often produces better results for complex tasks. It also makes debugging easier since you can examine the output at each step in the process. The third pattern is branching logic. This is where your system makes decisions about what to do next based on the content or classification of LLM outputs. For instance, your system might analyze a customer message, determine if it's a complaint, question, or feedback, and then execute different processes for each category. This adds flexibility while maintaining predictability. It's particularly valuable for customer service applications where different types of inquiries require different handling. Next comes the feedback loop pattern. Here, an LLM generates content, then another process, which could be another LLM or a different system, evaluates that content and provides feedback. The original content is then refined based on this feedback. Think of this as adding a quality control layer that can significantly improve output quality. We found this approach essential for high-stakes content where accuracy and quality are non-negotiable. The tool using pattern gives your LLM the ability to call external functions when it determines they're needed. For example, when asked about recent events, the system might recognize it needs current information and could call a web search API. Similarly, if it needs to solve a math problem, it can use a calculator tool. This approach greatly expands what your AI can do by letting it use other programs when needed. Finally, we have the autonomous agent pattern, where the LLM decides its own sequence of actions, including what tools to use and when to use them. It constantly checks for how it's doing, and it changes its plans based on what it learns along the way. This gives you the most flexibility, but it's also the hardest to make reliable. It works best for open-ended tasks where you don't know the exact steps needed to solve the problem ahead of time. The key insight is that simpler patterns are the easiest to test, they're more predictable, and often more than sufficient for most business applications. At Toratech, we typically start with the simplest approach that might work for specific problems at hand and only add complexity when we've confirmed it's actually necessary. This incremental approach helps deliver reliable systems that solve real business problems without unnecessary complexity. Core concept 3, advanced techniques. Now let's dive into some more advanced techniques that can take your AI systems to the next level of reliability and performance. One powerful approach is structured output control. Instead of letting your LLM generate free-form text, you define specific formats like JSON or XML that it must follow. This dramatically improves your ability to process and validate responses programmatically. We implemented this for a financial services client who needed consistent data extraction from documents. Their error rates dropped by over 70% simply by enforcing structured outputs. Another technique is called multi-model orchestration, where you combine different AI models for different parts of a task. For example, you might use GPT-01 for complex reasoning, but a smaller specialized model for specific domain knowledge, and vision models for image analysis. This strategy gives you the best mix of speed, accuracy, and cost. For example, we built a healthcare application where a focus model first spots medical terminology, then a more powerful model takes care of the broader interpretation and reasoning. Context window management becomes crucial as your applications scale. LLMs can only process a limited amount of text at once. This is their context window. When dealing with long conversations or documents, you'll need strategies to work within these limits. You can summarize previous exchanges, break documents into smaller chunks, or prioritize the most relevant information. Without proper context management, AI systems often start failing randomly or producing inconsistent results when processing longer text. They're simply running out of space to hold all the information. As you refine your AI system, controlled randomness gives you precise control over its creative behavior. Think of it like adjusting a dial between predictability and creativity. By tweaking using settings like temperature in the LLM, you determine whether responses should be consistent and factual or varied and imaginative. For objective tasks like customer service or data analysis, keeping this setting very low ensures predictable, accurate responses. But for creative applications like content generation, increasing it produces more diverse and interesting outputs. Another advanced technique that builds on basic retrieval is hybrid retrieval systems. Rather than just using one method to find information, these systems combine multiple search strategies. They might use vector similarity for conceptual matching, traditional keyword search for exact terms, and filters based on document types or categories. The key insight about these advanced techniques is that they address specific challenges rather than being universally applicable. Understanding exactly which problem you're solving and choosing the right technique for that specific issue is far more important than implementing the most sophisticated approach possible. When implementing these techniques, start with a small proof of concept to validate the approach before scaling up. Many advanced AI systems fail not because the concept was wrong, but because the implementation details weren't thoroughly tested in realistic conditions. Core concept 4, scaling and reliability. Moving from a working demo to production-ready AI systems is where many projects fall apart. The controlled environment of development is vastly different from the chaos of real-world usage. The first major challenge is handling unexpected inputs. In development, you test with reasonable, expected queries, but real users will ask questions in ways you never anticipated, using terminology you didn't account for, or they completely misunderstand what your system does. Your AI system needs robust error handling and graceful fallback mechanisms for these situations. And then, when you try and scale these systems, it introduces another dimension of complexity. A system that works perfectly with 10 users, but might collapse under the load of, thousands of users. This isn't just about technical infrastructure. It's about how patterns of usage change at scale. When more people use your system, you'll encounter many more unusual situations that your system wasn't designed to handle. This brings us to testing strategies. Traditional software testing approaches aren't sufficient for AI systems because of their probabilistic nature. Instead, you need to implement evaluation across multiple dimensions. First, accuracy testing. How often does your system produce correct answers across a diverse test set? Second, robustness testing. How does it handle deliberately challenging or weird questions designed to confuse it? Third, consistency testing. Does it provide similar answers to similar questions? And fourth, safety testing. Does it avoid harmful, biased, or inappropriate outputs? To test properly, you need to create a wide collection of example situations that your AI will face in the real world. If you're building a customer service AI, you should test it with all kinds of questions customers might ask, including unusual requests and questions they might phrase in confusing ways. You also need to add safety features, which we call guardrails. These act like protective barriers that stop your AI from saying things that are wrong, harmful, or inappropriate. Good guardrails work at several stages of the process. They check what goes into the AI, filter what comes out, and keeps track of patterns to catch problems that might develop over time. For example, before sending any AI-generated content to users, run it through a separate validation process that checks for factual accuracy, inappropriate content, and alignment with your brand voice. This additional check can prevent embarrassing or harmful outputs from reaching users. What happens when these principles are ignored? Well, we've seen major tech companies release chatbots that generated fabricated information, or they recommended dangerous actions, and they even produce offensive content. These failures damage brand reputation and user trust, and they're incredibly difficult to recover from. Remember that AI systems don't just break in technical ways, they can break while continuing to function. Your AI could generate answers that sound perfectly reasonable, but contain false information. And if you're not carefully checking its outputs, these errors could go completely undetected. The path to reliable AI systems requires a mindset shift from does it work in my testing to how might this fail in unexpected ways. This defensive thinking is what separates robust production systems from impressive but fragile demos that you're seeing online from all these other people. Now let me wrap up with some practical tips that you can apply immediately when building AI systems. First, start with the simplest possible solution. Before jumping into complex agent architectures, ask yourself, could I solve this with a well-crafted prompt in a single LLM call? Build the minimal viable solution first, then add complexity only when it's necessary. Second, implement proper testing from day one. Build a collection of test examples that covers the different types of questions and requests that your AI will need to handle. Run regular tests with these examples and keep track of how well your system performs each time. Too many AI projects fail because their developers just try a few examples and think, oh, this looks good, instead of measuring actual success rates. Third, build robust guardrails into your system. Before any AI-generated content reaches users, it should pass through safety checks and verify it's accurate, appropriate, and aligned with your requirements. Even major companies like Amazon faced embarrassment when their chatbots claimed to be human or provided inappropriate responses. Fourth, watch how your AI performs after you launch it. Set up tools to track both technical performance and whether users are happy with the results. Create alerts that notify you when something unusual happens. Keep in mind that AI systems can keep running even when they start giving worse answers, so you need to actively look for these problems. Fifth, be cautious about scaling too quickly. Start with a limited number of users, then expand gradually as you build confidence. When Apple rushed their AI features, they had to pull back due to accuracy issues. And try avoid chasing the latest AI trends just because they're popular. Don't attempt to build fully autonomous agents before mastering simpler patterns. Oh, and of course, never release your AI to real users before you thoroughly test it. The difference between impressive demos and reliable systems isn't having the most advanced technology. It's careful planning, thorough testing, and honestly understanding what your AI can and cannot do well. And that's it for this video. We've covered a lot of ground, from understanding what AI agents truly are, to exploring different patterns for building AI systems, and then to implementing advanced techniques and ensuring reliability at scale. The main takeaway I want you guys to remember is this: building effective AI systems is about finding the right balance between capability and reliability. Start simple, test thoroughly, and only add complexity when you've proven it's necessary. If you're a developer looking to apply these concepts but don't want to start from scratch, we'll soon be releasing free resources where we package all of the patterns and techniques we've discussed today into a comprehensive framework that helps you build reliable AI systems faster. It'll include pre-built components for all the patterns we've covered, the testing frameworks we've also talked about, guardrail implementation, and detailed documentation. And you'll also get access to our developer community where you can ask questions and share your progress. If you found this video helpful, our channel has more in-depth content on AI development. I recommend checking out our previous video where I speak on how to make money using AI in 2025. Thanks for watching, and if you enjoyed this content, please hit the like button and consider subscribing to support the channel. Drop a comment if you guys have any questions about anything we've covered today, and I'll do my best to respond to as many as I can. Remember, we're all figuring this out together, so I look forward to seeing what you create with these techniques. See you in the next video.